So hello guys, today we are going to do leetcode question that goes by the name boats to save people. The question number is 881 and it's a medium leetcode medium question. Okay, so we'll follow the same pattern. We'll first try to read the problem statement, understand what the problem says, and then we'll go on to the solution. Okay, so let us start. What you are given is, you are given an array people where people of I is the weight of the ith person and an infinite number of boats where each boat can carry a maximum weight of limit. Okay, so you are given an array people. Basically this is the array you are given, array. Okay, and it is of size n, suppose. And what are the contents of this array? The contents of this array are, basically if there are n is the size, then n are the number of people, and this array contains the weight of those people, the weight of those people. Okay, so if my array contains 10, 20, 30 and 40, these are the weights of the people. This is the weight of the person 1, person 2, person 3 and then person 4. Okay, each boat carries at most 2 people at the same time. Okay, so what I have infinite number of boats. Okay, infinite number of boats, and what I am given is my boat can carry either 1, 0 or 2 persons. So at most 2, at most. That means less than equal to 2 persons. Okay, so provided the sum of the weight of those people is at the most limit, return the minimum number of boats to carry every given person. Okay, so what we are given basically here is each boat can carry a maximum of 2 persons, a maximum of 2 people, and the sum of weights of those people should be less than equal to limit. If the weight of both of those is exceeding the limit, then only one person can travel. Okay, and it is obvious that the maximum weight of any given person will be less than equal to limit, so that all the people can be transmitted. Suppose basically your limit is 30 and the person is of 80 kgs, he cannot sit on this boat. So, or if my limit is 30, then all the people's weight will be less than equal to 30. Okay, so this, if x is the weight, then all the weights will be less than equal to 30. This is the question. Basically you are given with some people and their weights. Okay, this is a summary, and this is a boat which can carry 0, 1 and 2 persons with a limit. You have to find out the minimum number of boats so that these people can travel to the other end. Okay, travel to the other end or travel anywhere in the world. Okay, travel to the other end. Okay, so what are the minimum number of boats? You have to find the minimum number of boats. Okay, what I can do? You might be thinking like, suppose what can be my approach in this question? Okay, if I just take this test case 1, 2, 3, 2, 2, 1. Okay, if this is my test case, in the boat you can have either 0, 1 or 2 people. Okay, and you have to minimize the number of boats. So for minimizing the number of boats, you will be thinking like each boat should contain the maximum number of people, because if boat is not to its capacity, then we are wasting a space. Okay, so I have to make sure that maximum number of boats contain as it's at its full capacity. Okay, are at its full capacity. So I have to make sure that maximum number of boats are full. How can I make sure of this? That my maximum number of boats are full. Okay, maximum number of boats are full. Okay, just try to think like this. If 0, 1 or 2 people can be there, not 0 basically, why would I take a boat with 0? 1 or 2, let us consider 1 or 2. Okay, so 1 or 2 people can be there, and I have to, if to minimize the number of boats, I have to make sure that boats goes at its full capacity. So if I have to fit 2 people on a single boat, what can be my algorithm like? What can be my algorithm like? Okay, suppose I am given with the weights, one is of 10 kg, one is 20 kg, other is 20 kg, one is 30 kg, and another is 40 kg. Okay, these are the people that are given. Okay, suppose you say like this. Okay, think like that. If I am given a boat and I have to fit 2 persons, this is my priority that I have to fit 2 people. Which 2 people can I fit here? Which 2 people can I fit here? Can I fit like the most healthier ones? Most healthier ones. If my limit is basically 50, limit is basically 50. Okay. So can I fit the most healthy one in the sports? Is it the optimal choice? No. If you think carefully, no. Because see, if one's weight is 40 and the other's weight is 30, okay, it would be resulting in overflow, because this would be resulting in 70 weight and the boat will not be able to handle it. Think like that, because in the boat, if you are fitting 2 healthy people at the same time, then there are higher chances that the boat's limit will exceed. Okay, so this cannot be my choice. Like, you cannot take the higher elements at once. Like, 2 high elements should not be there at together, because this can be a risk. This may not be a risk every time. Why? Because see, if I am given with 10, 10 and 10, okay, here taking the 2 won't exceed my limit if my limit is 30. Okay, but this thing is risky. If I take the maximum once, then it is a risky case. Why? Because this can lead to my limit exceeding. Okay, this can lead to my limit exceeding case. Okay, so this case crosses out. Okay, I cannot use this for obvious reasons that I told. What can be my second case? Okay, bhaiya, we cannot fit the healthier ones together, but what if I fill the leanest ones, like the ones with the least weight? Yes, maybe you are right. If the boat can handle 1 or 2 persons, yes, I can fit this 10 and 20 together. Okay, yes, I can do this. Then what about this? Okay, I have used one boat. What about this? My limit is 50. Okay, what about this? Can I fit 30 and 40 together? No. Okay, so they will be on different boats. 30 would be utilizing one boat, 40 will be utilizing one boat, 50 will be utilizing one boat. Okay, so in this case, what are the boats that I use? 1 plus 1 plus 1 plus 1. In this case, 4 boats are being used. Okay, 4 boats are being used. Okay, yes, bhaiya, this would work, but is it an optimal choice? Okay, is it an optimal choice to make? Because once I am done with the smaller ones, once I am done with those values that are summing up less than equal to limit, I'm basically out of bounds. Now for every index, I will have to use a boat. So is it a good choice to make? Think carefully. No. Okay, because after this, if you observe, I have to use one boat for each, and this is not something I want. I want to reduce the number of boats. So for this, I have to select the elements such that I have to select the people such that the boats minimize. Okay. Now think of like this. These are the weights of the people that are given. My limit is 50. Okay. I have rejected the highest ones together. I have rejected the lowest ones together. Now what can be my optimal choice? Okay, we are not taking the highest ones together. Okay, I am not taking the lowest ones together. Okay, but what seems to my optimal choice is, what if I put the highest and the lowest ones together? Okay, one highest, one from highest, and one from lowest. Okay, and one from lowest. And but there's a condition that the sum of them should be less than limit. Should be less than limit. What about this? What about this? If you think carefully, this would be resulting in an optimal solution. Why? Because see, if this is my board, here is a one healthy person like this. Okay, so I now suppose he has a weight 30. Now I have space for only 20. My limit is 50. He is occupying a weight 30. My choice is 20. So if I have some weight, I have some person that is having a weight less than equal to 20, I would definitely take him. I would definitely take him and send him on the boat together. That is how I'll reduce the number of boats that are being used. I'll reduce the number of boats that are being used. Okay. So a healthy person with a slim one is the best choice to make. Is the best choice to make. Best choice to make. Because there are lesser chances that I would go out of limit. I would go out of limit. Yes, there are chances, but it is still better than these choices. It is still better than these choices. Okay. So for getting all the maximum and the minimum together, what I can do is, what I can do at this chart, suppose if these are my persons with the weight 30, 40, 20, 10 and 50, I have to segregate the lowest ones and the highest ones together. What I can do? Yes, sort them. Sort them. Okay. So my array would look something like 10, 20, 30, 40 and 50. Okay. Array would look something like this. Okay. Now I have the highest ones together and the lowest ones together. Basically they are just standing in a line from the lowest to the highest. Okay. Now what is my optimal choice to make? Place the higher and the highest and the lowest together. Highest and the lowest together. But following a condition that it should be less than or equal to limit. If it is not less than or equal to limit, just use the highest ones. Just use the highest one. Okay. Use the highest ones because the lesser ones can be used in future. Can be used in future. Okay. What I'll do, simply simply think of like this. I have two guides. Okay. One would be responsible for selecting the lowest, one would be selecting the highest. Okay. I would be placing one guide to the right, that is the highest, for selecting the highest ones, and one guide to the left that will be selecting the lowest ones. Okay. Limit in this case is 50, and as you can see all the values are less than or equal to 50. Okay. I'll initialize the number of ports as 0 in the start. Initialize the number of ports as 0 in the start. Now I have to make an optimal solution such that the number of ports are minimized. Let us see what we just decided is the better option or not, and I'll compare it with the other two cases. Okay, so one guide is at the start monitoring the lowest ones, and one guide it as the highest monitoring the highest ones. Okay, so yes, we'll start. My limit is 50. Okay, so one pointer is here, one pointer is the start, one pointer at the last. Okay, I'll try that this is a boat. Okay, my choice is to place two people together. I'll try, but if this is not happening, I'll place one people and increase my boat number. Okay, so what I'll try is, I'll try to place 50 and 10 together. One pointer is at 50, one pointer is at 10. So 50 plus 10 is equal to 60, and that is higher than my limit. Can I place them together? No, because it is higher than my limit. So okay, I cannot place them together. Okay, I'll send my 50 alone. My boat would increase. Okay, and as I have used this person, like this person has already went, my guide would go to the next other person. My guide would be here. Okay, this 50 has gone and it has increased my boat number. This 50 is gone. Okay, I'll come to the 40. Still, my goal is the same. I have to reduce the minimum number. I have to reduce the boats being used. Okay, I try to put this 40 and 10 together. 40 and 10 together. Is it less than equal to my limit? Yes. Okay, so what in this case I'll do? I'll send them together. Basically, this 40 is a healthy one. See, 40 is a healthy one. 10 is a slim one. I try to send them together in one boat. So 2 people are done. And only one boat is utilized. So this 40 and 10 would go together and both the guides would move one step forward and backward. How? This 40 is done. Now I don't have to think about this. My guide would come here, high guide would come here, and my low guide would also move one step forward. My low would come here. Okay, and obviously the boat number would increase. So I have utilized 2 boats till now. Okay. I'll come to the next set of people. When I come here, I just try to, still my goal is the same, to minimize the number of boats. I'll try to put them together in one boat. So this 30 and 20, I'll try to put them together. This 30 plus 20 is resulting to 50. And is this less than equal to my limit? Yes, exactly. So what I'll do is, I'll still try to make them go together and reduce the number of boats. So yes, they can fit in one boat and I'll send them together. Okay, my guides would increase and decrease. So my low would come here, my high would come here. Okay, and yes, I am done with this 10, 20, 30. All the people are done, and this is where I stop. But before stopping, just increase this count. Okay, so 3 boats is the answer that I am looking for. In 3 boats, I can send all the people. Okay, I can send all the people. This is the most optimal answer. So boat number is 3. Okay, boat number is 3. Okay, now I'll try to show you why the highest ones and the lowest ones, like the other 2 approaches, are why not to be followed. Suppose this is my answer. This is the same test case. These are the people, and I will try to put the maximum ones. I'll follow this strategy ones, highest ones. Okay, boat is initially 0. Okay, boat is initially 0. Okay, so 50 and 40, the highest ones would be together. Okay, can I put them together? No. So this 50 would be utilizing one boat. Okay, my boat number would increase. I am done with it. This 40, yes, this is a good choice. Like 40 is less than limit, but can I combine this with 30? No. So I will have to send it alone. And my boat number would increase. Okay, my boat number has become 2. I'll come to 30. This 40 is also done. I'll come to 30. Okay, 30 is less than limit. I'll try to add this 20 also. Okay, 20 is added and it still remains less than limit. So yes, they can be sent together. Okay, so this and this will be sent together. Boat number would increase. Boat would go to 3. Okay, I'll come to the next person. I'll come to 10. Is there any other person to just use with, like to pair with? No. So the boat number would increase. And in this case, what is my final boat number? Yes, 4. And what was in the previous case? 3. So is it an optimal choice to make? No. Okay, so this choice is rejected. Okay, now following the lowest ones. 10, 20, 30, 40 and 50. Okay, I'll try to pair the lowest ones. I'll come to 10. Okay, is it less than my limit? Yes. I'll try to pair it with the next lowest 20. Okay, yes, it is still less than limit. I can pair them and send them in one boat. So yes, this is used, this is used. Boat becomes 1. I'll come to this 30, I'll come to this 30. Okay, I'll come to this 30. 30 plus 40, can I pair? Is it less than my limit? Less than equal to my limit, that is 50. No, no. So I have to send this 30 alone. Okay, my boat number increases, boat number becomes 2. This 30% is also sent. I'll come to this 40. Can I pair 40 with 50? No. So I have to still increase the number of boats. My boat number becomes 3. Okay, my boat number becomes 3. This person is sent. I'll come to 50. Can I pair 50 with anything? No. So boat number would still increase. So number of boats required in this case is 4. In this case, lowest ones it would require 4. Highest ones would require 4. What about highest plus lowest? Yes, this requires 3. So what is my optimal solution in this case? Yes, combining the highest person with the lowest person. Because if one person is taking so much space, then the least space should be occupied by the least persons. Okay, if there are like a healthy person on the boat already, I'll not place another healthy person with him. Okay, I'll select the leanest of them and I'll place him with them so that the boat won't sink down. This is the approach that we are following. Okay, I'll try to take up one more test case and then we'll move on to the code. Okay, which test case should I take? 3, 3, 3, 3, 5. This third test case we will take 3, 5, 3, 4. 3, 5, 3 and 4. Okay, what is my limit in this case? Limit is gonna be 5. Okay, I have to first segregate. What is my first step? I have to segregate the lowest ones and the highest ones together. So what I'll do is I'll simply sort them. 3, 3, 4 and 5. Okay, limit is 5. What is my approach? Highest plus lowest ones together. Highest point is here, lowest point is here. Okay, boat capacity is 5. Can I combine this 5 with 3? No. Boat is initially 0. Can I combine this 5 with 3? No. Okay, I'll utilize this 5. I'll send this fifth person, this 5-8 person, and I'll increase my boat counter. So boat counter becomes 1. This 5 person is sent over to the another show. Okay, I'll come to this. My high pointer would come here. Can I combine this 4 with 3? 4 with 3. Is this less than my limit? Is still less than equal to 5? No. So yes, the number of boats increases. Boat become 2. I'll come to this 3. I'll come to this 3. Okay, this person is also used, like sent to the another show. Okay, this is my high pointer 3 and this is low pointer. Can 3 and 3 be combined? Is this less than equal to my limit 5? No. So yes, number of boats would still increase. Okay, what about this 3? Okay, now my high and low are at the same place. Okay, will I still check for this pairing? 3 and 3? As the people are equal weight, like the same person. Okay, it is completely fine to check. Because the number of boats would still remain the same. The number of boats added would still remain the same because the person with the person's weight added, or if it is not added, only one boat is increased. Okay, so this would be a scenario like I would go till my low pointer is less than equal to my high pointer. Why? And my number of boats become 4 obviously. Why? Because this is the edge case, the middle case in which I have to consider the same person twice. Doesn't matter if I check or not, because in that case only one person is there, so a boat will definitely be needed. Okay, so in this case the answer is 4. Is my answer 4? Yes. I'll try the second test case also. I'll just sort it. One person is here, one person here. High plus low I have to combine. Okay, the boat capacity is 3. I'll try to pair up the highest with the lowest ones. So 3 plus 1 can be paired. No, because for obvious reasons, basically it is exceeding the limit. greater than 3. Okay, so I'll use one boat and my high pointer would decrease. I'll use one boat. Can 2 and 1 be combined equal to 3? Is there less than equal to my limit? Yes. So yes, boat is equal to 2 and both the high pointer and low pointer would increment and decrement respectively. In this scenario, it is both the high and the low pointer are pointing to 1 index only. And as there is only one person, a boat is needed for sure. So it doesn't matter if you are checking for the summation, again a boat is needed. So in this case, boat would increase. And is 3 my answer? Yes. Okay, so we are choosing the higher plus low strategy. What we are doing is taking one point at the lowest point, one at the highest point. If the sum of them is less than equal to a limit, then I'll increase my I pointer also, basically low pointer also. And if it is greater than limit, then I'll simply decrease my high pointer. But in both the cases, my answer or my boat counter should increase. Okay, now I'll try to code it for you and let's see how simple it is to code. People.size. Okay, my low pointer would be at the 0th index, but first I have to segregate. The high with the low, basically the highest ones together and the lowest ones together. I'll arrange them in a line. People.end. Okay, so now I have segregated the lowest and the highest ones together. Okay, one pointer or one guide would be at the lowest person, would be pointing to the lowest person currently, and one pointer would be pointing at the highest person currently. Till what point I'll continue? Yes, till my low pointer is less than equal to my high pointer. I'll check for the scenario. If a high person can be combined, a low person can be combined with the high weight person, and if that is less than equal to my limit, I'll simply increase my low person counter also. Basically, I'll tell the guide to move one step ahead, because that low person, I'll sending him in the boat with a healthy person. Okay, so the low pointer would also increase and my high pointer would also decrease, because the healthy person is already going. And in both the cases, what happens to the boat counter? Boat counter was initially 0. So in both the cases, the boat counter would increase. And at the last, what I'll do is I will simply return my boat counter. I'll try to run it. Okay, I'll try to submit. So yeah, submitted successfully. Okay, so I'll just try to explain you the code again. What we are doing is basically sorting the people. I am segregating the lowest ones to the highest ones. Basically, I am making them stand in a line. One guide is pointing to the lowest weight person and one guide is pointing to the highest weight person. And what should be my ideal case? I have to combine this highest ones and the lowest person. If the combined weight of them is less than equal to my limit, I can send them in the boat and both of the guides would move one step ahead. And if both of them cannot be sent in a group, then the highest person would go alone, because this lowest person can be used for the future. Okay, and in both the scenarios, whether the two people are going on the same boat or the highest person is going alone, both the scenarios, my boat counter would increase. Okay, so, and at the last, what I'll do is I'll simply return my boat counter. So this was the overall code. What about the time and the space complexity? If you just try to notice, the guides are moving from the two ends towards the middle. So there is only one iteration, starting from the last to the mid, starting from the starting point to the mid. Okay, so both are covering n by 2 distance. If combined, it becomes O of n. It becomes O of n. So what is my time complexity? What is my time complexity? My time complexity becomes O of n by 2 plus n by 2. So that becomes O of n. Am I using an extra space? Okay, no. This sorting would also take n log n. Okay. Segregation also take time. So n plus n log n is my time complexity. Okay. What about my space complexity? My space complexity, am I using an extra space? No, just the simple variables. So the space complexity is O of 1. So this was the overall solution to the question, boats to save people. I hope you guys like the solution. If you have any doubts regarding the solution, you can just ping it down in the comments. If you like the solution, don't forget to like, share, subscribe. Thank you. Have a nice day. Bye-bye.